Okay, a very good evening to everyone. All right. Or since everyone are watching our this session on Facebook of the channel of the Astronomical Society of Penang and also the YouTube channel of our society. All right. So again, very good evening, good afternoon, good morning. All right, everywhere in the world. All right. So I just introduce our presenters for tonight. So on the further up there is our Mr. Lai Hung Jun. All right. He's doing his doctoral studies in astronautics and aeronautics. All right. And then on the left side is our Ryan Arkadri. All right. He is, I think, now doing his, we call it Form 1 studies in Malaysia, equivalent to Year 7 in the UK and Grade 7 in the US. All right. And below you have our Marcus Chung. Again, he's studying Form 1 in Malaysia and then what they call Year 7 in UK and Grade 7 in the US. All right. And on the, of course, Chiu Zheng Yang, he just finished his Form 5 studies. All right. He's about to go to university. So, and I'm Dr. Chong, president of the Astronomical Society of Penang. So, Lai Hung Jun and myself and Marcus and Zheng Yang are doing in Penang. And Ryan Arkadri is now in KL, Kuala Lumpur, capital city of Malaysia. All right. So, we start off with I present now my first picture. Lai, can you see my picture? Please answer. You're unmute. Can you see my picture?
I see your screen.
Okay, now can you see the airport screen?
Yes, yes.
Okay, so we start. So again, this is the actual picture of the day, archived for March, what they call 2021. You look at the first one, which is today, 27th of March. Okay. Just wait a moment. The line usually is quite fast, but I don't know why it's a bit slow now. Okay, now we look at this. Wow. Whoa. I'm sure many of you have seen before, all right? Now, before we start, let's look below here. Now, you look here, you have two guys here, Professor Robert Nanuro of the Michigan Technological University, all right? He's what they call Professor of Physics there, and our Dr. Jerry Bonnell of the University of Maryland, College Park. He's also working in NASA Goddard Space Science Center and in the University of Michigan, College Park. All right. So these are the two people who decide who are the ones that are given. And there are 4 Malaysians already have airport picture. So look at the first one. So this picture is, of course, we know for exploring the antenna. This is a famous picture. So basically, this is 2 galaxies during collision. All right. And taken by Bernard Miller. All right. He's an amateur astrophotographer from America. All right. So basically, you have these 2 galaxies are colliding in the constellation of Corvus. Corvus will mean the crow. All right. And they have named NGC 4038 and NGC 4039. NGC means New General Catalog. So you can see they are colliding, and during the collision, you have seen the 2 tidal tails. So this is like gravity that is pulling out the stars from this. So these are the 2 galaxies that are under shock. All right. So there are two possibilities. One is that these 2 galaxies will collide and merge as one galaxy, or maybe if the velocities of collisions are very fast, they will interpenetrate each other and fly away, never to come back again. And the size of these what they call 2 galaxies is about 500,000 light years, which means that it is about 5 times the diameter of the Milky Way galaxy. All right. So this is it. And of course, in the foreground star, you have here a star here with 4 spikes. Means that Mr. Bernard Miller's telescope has 4 veins in the spider holding the secondary mirror. All right. This is the brightest star. And of course, the other stars are also in our Milky Way. All right. Because they're not bright enough, you don't see the deflection spike. But the 2 galaxies, of course, are very far away. Of course, here it explains here that it's not possible that the stars in galaxy A and galaxy B will knock at each other. No, because the space between the stars are very vast. Very unlikely to have many stars colliding. Maybe from one galaxy A to galaxy B, the star one of the stars can collide with another star. But most of the other stars from the galaxy will interpenetrate through the space between the stars. But remember, the space between the stars got what? atomic hydrogen, what they call ionized hydrogen, got molecular clouds. So these are the ones that will interact and they will give up what? Heat, infrared, even radio waves, right? So don't go inside there and use your handphone. You can use your handphone because the background is full of radio waves, all right? So these are the two interpenetrating galaxies called the famous antenna. And you see the tidal tails, right? Pull out very far away. And in fact, Hubble has seen a lot of sights. Well, another one is called the mice, you know. Two of the galaxies, they interpenetrate and the tails stretch out very far. So in the years to come, our own Milky Way will also have a galactic collision, galactic accident with the Andromeda galaxy, which is coming towards our Milky Way galaxy. But that will not occur until a few billion years in the future, right? Now look at the second picture. I enlarge the word first. Okay, March the 24th. All right. Aurora and lightning on Jupiter. All right. And this is our NASA JPL mean Jet Propulsion Laboratory, Caltech. This is in our Pasadena, California. And SWRI is our Southwest Research Institute. It's a private research institute in Texas. And this picture was actually taken by, of course, the earlier mission from NASA, but processed by Natalia Lewandowska. So Natalia Lewandowska is a visiting assistant professor in astronomy in Haverford College in Pennsylvania. And she originally comes from Germany, right? So she took from the archive of NASA and processed this picture. So you see here, wow, you see the aurora on the north pole of Jupiter, and then they enlarge this part. So aurora, we know, are the solar wind particles from the sun, electrons and protons, traveling at hundreds of kilometers per second, smash into the upper atmosphere of the northern part of Jupiter and will excite them. Or in other words, you use the word fluorescence. So when the atoms are excited, the electronic levels will drop to a lower energy level and will give off light, right? But what they see here, you see there are knots, you know, there are knots. Now remember, below it, you see the whole area of this Jupiter. So this is a big area, no? So that means this whole aurora in the northern polar region of Jupiter, you can feel in the whole Earth inside, all right? And here is a lightning strike. This is a lightning, all right? And in fact, many years ago, during the time of Pioneer and this Voyager, the spacecraft that flew by Jupiter, they already detected this lightning on Jupiter, all right? And they also saw the aurora. And so here, this is the lightning, all right? And the scientists have estimated that the power of the lightning in Jupiter are many times the lightning on the Earth, all right? So this is it. This is taken by our Juno, all right? Remember a few years ago, NASA sent a spacecraft called Juno that flew by and entered orbit around Jupiter, taken by Juno on May 24, 2018, right? So I think that's it. Okay, there's one more thing here. They say that actually they have found out that in Jupiter, most of the lightning are found in the polar region, North polar region or South polar region. But on the Earth, it's opposite. Most of the equatorial regions have the most lightning storms, right? In the polar region on the Earth, less lightning storm. But in Jupiter, it's in the polar regions, right? So I stop now. So the next person can continue, which is Ryan. Okay, you're on, Ryan.
Can you see my screen?
Just a moment. Not yet.
I can. You just need to go to the APOD picture.
Yeah, go to the airport picture.
Okay.
Yeah, we can see it now. I can see now.
Okay. As Dr. Chong said, my name is Rayan. I'm 13 years old, and I have taken my SAT waiting for university decisions. Okay. Now, the first photograph that I'll be presenting today is for March 23rd. Its name is Mars over Duddle Stone Circle. It was taken by Ged Kivlahan. He is in England. He's from England. And this photograph was actually taken in England. So let me, can you see the photograph? Okay. Now, basically, this photograph is a composition of two different photographs. You've got the part that contains Mars over here. So you've got Mars. This part right here is actually Mars, the planet Mars. And over here are the Duddle 5 stones. Now, the reason why Mars is so bright and big in this photograph is because this was taken during the Mars opposition of 2020. This entire photograph was actually taken on the 10th of October last year, 2020. And for that reason, Mars was this big and this bright, and it won't be this big and bright until the year 2035. Now, the second thing that we have here are the Duddle 5 stones. These stones, they are an example of something called a stone circle. A stone circle is basically an arrangement of stones in a circular fashion. And it is believed that they have some relation to astronomy and to the heavens. And for that reason, this photographer, who's actually a landscape artist, decided to take a photograph with Mars in it to show the relation between these stones and possibly what the people who built them thought to have their relation with the stars, and in this case, with Mars. Now, the 5 Duddle stones, they're located in Duddle, which is in Northumberland. This is Northumberland right here. You can see it. It is just across, it's south of Scotland, so it should be visible right here. Okay. It's right there. So this area here, this is Northumberland, and it's south of Scotland. Now, to give you a better idea, you see these are the Duddle 5 stones, and these spaces here used to have an additional 2 stones whose slots were found in the 1890s. So that's basically the first photograph. Moving on to the second photograph, this was for March the 22nd. Its name is From Auriga to Orion, and it was taken by Alastair Simon. So let me move back here. So Alastair Simon, he is the Vice President of Storage Development at IBM. And this photograph was taken at the Woodlands Observatory. It's a private observatory of his located in Tucson, Arizona, in the United States. This photograph, it is basically full of nebulae. You see, what you can basically see is the Auriga constellation and the Orion constellation, hence the name From Auriga to Orion. Now, this photograph, it is what you call a mosaic, meaning that parts of the photograph were taken separately at great detail and then all put together to create this entire photograph. Now, how many photographs were used to combine together into this? Oh, a total of 34 photographs were required to make this picture. And all of them use the filters of hydrogen alpha, sulfur, and oxygen, which color mapped the different elements to specific colors that you see on the screen. So parts that are yellow, for example, may map to a combination of hydrogen and sulfur. Now, as for what you can see in the photograph itself, right over here, we have Orion's Nebula. It is a nebula that doesn't exactly have a distinct border, and it's actually 1,300 light years away from Earth. Now, right next to that, you can actually see right here, these lines, okay? These lines are formed by the 3 stars, Mintaka, Alnilam, and Alnitak. They form an asterism, basically a pattern of stars that's not a constellation. They form the asterism called Orion's Belt. At the same time, you can also see towards Auriga, the Flaming Star Nebula. The Flaming Star Nebula, it's actually a nebula, not a star, and it's named the Flaming Star Nebula because the star which is in the center of it, named AE Aurigae. This star actually has, when it glows, creates a smoking optical illusion around the nebula. So you can also see other stars here, Betelgeuse, Rigel. There are many things in this photograph. To go through all of them would take very long, but if you want to learn more information, you can head over to the APOD website. Now, when Mr. Simon took this photograph, his main purpose was to show the number of nebulae that are around here and to relate them to each other, to show that these stars are as close to certain objects as other things. Now, we would then move on to my last photograph. The last photograph here that I have is the Antikythera mechanism. This photograph is for March 21st. It's the APOD for March 21st. And this thing is just a beauty. This thing, believe it or not, is actually a computer. Yes, it is a over 2,000-year-old computer. It is an international treasure. And it was found around the island of Antikythera, which you can see right here. The island of Antikythera, it is near Greece. And so the entire distance from Malaysia to the island of Antikythera is about 8,700 kilometers. Now, what makes it so special is what I said just now. It is over 2,000 years old. Now, as for what its purpose is, well, this thing as a computer has significance, especially in astronomy. You see, this device was capable of predicting solar and lunar eclipses. It could tell you the relation between the 5 planets, Mercury, Venus, Mars, Jupiter, Saturn. Those are the 5 planets known at that time. It would relate them and tell you their position relative to Earth. It would even be able to tell when the 4-year Olympiad cycle started, which marked when the ancient Olympic Games were held. Now, when this was first discovered, people did not know what it was. It was only in 1951 that this man, Derek J. de Sola Price, realized what it was, which is exactly what I've just told you. Now, what we see in this photograph, it is not the whole mechanism, though. It is only a part called Fragment A, which is one of the 7 major fragments right here. This part is Fragment A, which is what we see over here. And Fragment A, it has the biggest wheel, it has the biggest gear wheel of all of them, because the whole thing ran on gears. And I ran a calculation, and this entire gear, it's about 13 centimeters in diameter and has over 200 teeth, meaning that the width of one teeth would be something around the width of this little paperclip, just the diameter from this point to this point. So it was a very precise mechanism. And it is truly amazing that this thing existed 2,000 years ago. Now, as of now, we still don't know who came up with it, who built it, or why it was built. But as science and technology advances, who knows what we may find out about it. That will be all for my photographs.
So, Marcus, you can start your presentation.
Okay, you all can see my screen, right? Dojang, you're muted.
Go to the other screen, Marcus.
Okay, okay.
Yeah.
Okay. Okay, so hi everyone. As Dojang said, my name is Marcus, and I'm going to be talking about the APOD for March 17, March 16, and March 14 this year. So the first APOD I'll be talking about is I zoomed in so y'all can see the words. Now I'll zoom out so y'all can see the whole picture. So this is an old picture, obviously, as it has no color, and it's titled The Surface of Venus from Venera 14, which is a Soviet spacecraft, not the Americans. This is the Soviets on Venus. So this spacecraft Venera 14 was built by the Soviet Union, and it was meant to explore Venus. It only lasted for around 1 hour on Venus due to the intense heat on Venus, which is the second planet from the sun and is the hottest planet in the solar system. Not Mercury, which is the first, but Venus, the hottest planet in the solar system. Why? Because it has a very thick atmosphere that traps all the heat that come from the sun, making it the hottest planet ever. So it was taken by the Soviet Planetary Exploration Program, and it was processed by Donald Michel and Michael Carroll. And okay, over here you can see this is the camera cap that fell off when it entered into the atmosphere. And this over here, it's called, hold on, it's called a penetrometer. It's used to make scientific measurements on Venus. So it's supposed to determine the heat of the ground below Venus. And the next is the APOD for 16. And let me zoom out again so y'all can see the whole picture. As you can see, it's a nebula, and it's called IC1318, the butterfly nebula in gas and dust. So its name is the butterfly nebula, and it's like more like scientific name is IC1318, which stands, and IC here stands for index catalog. Okay, this whole thing here is called the butterfly nebula, and it's right over here in the constellation of Cygnus the Swan, right over here. It's this one over here. And in this star, Satyr, it's near, it's around, yeah, okay, here's a bigger picture. It's around this star called Satyr. You can see it, it's around near the Pelican Nebula, which is this nebula over here. And you can see this, you'll be able to see this. Here, the red here stands for hydrogen, the red parts of the nebula, and the green part, no, it actually stands for sulfur. The green part here stands for hydrogen, and the blue part stands for oxygen. And there's actually a theory on why the nebula is shaped like a butterfly. And some scientists believe that before the Butterfly Nebula was a nebula. It was a binary star, and at one point, the biggest star in the binary star system ran out of fuel and collapsed on its own weight. But as it collapsed, its temperature increased, and the heat reignited the core of the star and sent the outer layers blasting. But outside of the binary star system was a cloud, was the gas and dust cloud surrounding it, and it slowed down the expansion of the material from the star, and therefore it creates a butterfly-like shape. And I think that's it for this picture. I'm going to be moving on to my final picture for the day, 2021 March 14. I'm going to zoom out again to show you all what the whole picture looks like. As you can see, it's an aurora, and it's titled A Flag-Shaped Aurora Over Sweden. It was taken in this town called Kiruna, right over here. As you can see, it's in this part of Sweden. And this is an aurora in the shape of a flag. It's not actually a country's flag, but it looks like what a country's flag would look like. The top here is blue, and there's red, there's purple and blue, and there's green. The green comes from the Earth's atmosphere, and the red comes from space. But it's actually unknown where the purple comes from. But scientists think it's related to a strange blue aurora. So as you can see, this aurora is in the north, and it's called Aurora Borealis, and the auroras in the south are called Aurora Australis. And the reason this aurora formed was because a few years ago, the sun was really active, and it had this thing called coronal mass ejection, which is the sun ejecting very powerful plasma from itself. It caused a geomagnetic storm on Earth, which is basically huge change in the Earth's magnetic fields, and this is the visual result. Okay, I think this is it for me, and I'll be passing on to the next presenter. Dr. Zhang, you're muted.
Thank you. Can see, huh? Light can see on? Can, okay. Okay, so this is our, what we call March the 12th, 2021. As we see here, Messier 81. All right, we know it's for the 81 entry in the Messier catalog, which was started by Charles Messier, an amateur astronomer in France many years ago. And this is taken by our Mr. Wissam Ayub, all right, from Abu Dhabi in the United Arab Emirates. Now remember, in the Middle East country, you have the desert, you know, so very clear sky at night there, no? So you see here, it's a grand spiral galaxy, all right? So here are the stars with the diffraction spikes are in the foreground, which means that his telescope has a four spider that holds the secondary mirror, and you see the spiral arm. And we know that in this what they call any galaxy, you have the what they call galaxy, the two population star. This is a population one in the spiral arm, all right, and they're the younger star. And then you see the pinkish spot. Here, the new stars are being born at the furious rate. The blue also, pink and the purple, all right. But this is a population one star, the relatively younger star in the spiral arm, and they're in the disk. But in the bulge of the galaxy in the center, you have the population two, they're the older star. And the population one stars are rich in the metals. Now, in astronomy, metals mean anything heavier than helium is called a metal. So carbon, oxygen is still a metal, you know, but hydrogen and helium is not. So here you have rich in the heavier elements, all right, from carbon, oxygen until iron. And here are the population two, poorer in the heavy elements. So basically, it's rich in hydrogen and helium, all right. And of course, we know that in the center of this galaxy, there's a supermassive black hole. It's confirmed that in the evolution of most galaxies in the universe, they will always have a supermassive black hole in the center. So if you look carefully in this, I'll make the picture smaller now. Ladies and gentlemen, do you see the galaxy? Yes, I see the galaxy M31. Is it all there is? You may not understand the question. The question has a deep meaning. Do you see all that is? My answer is no. What is it? So basically, this is the 5% of the real matter surrounding this galaxy. So now the scientists know that the universe is made up of 5% real matter, meaning hydrogen, proton, electron, making you and me, your country and me, the Earth, the whole solar system, but 27% of dark matter, which we still don't know what it is, but scientists know it must exist, and 68% of dark energy. So 95% of the dark matter and the dark energy is not here, right? But no, it's not visible here, but it should be there, right? So whenever you look at the galaxy, you're looking at only 5% of what that exists. The other 95% is still not being what you call known, but the scientists know they exist, especially for many of the what we call cosmic microbial background satellites sent into space. Many years ago, COBE, Cosmic Background Explorer, then WMAP, Wilkinson Microbial Anisotropy Probe, and the recent Planck satellite. It's confirmed that the universe has 5% real matter, you and me, and the stars, and then 37% dark matter, which we don't know what it is, and 68% of dark energy. So you see here, this is beautiful. This M81, all right? This is it. So now we go to the next picture. March 11. Okay, I make it bigger first before I make it smaller again. Okay, March 11. Wow, this is a kind of a farmhouse, all right, in Illinois State in America. Remember, Illinois is where you have the state called city called Chicago, but this is not near Chicago. Illinois is a very big state, you know. So this is in the countryside, a beautiful one, and this is taken by Joshua Rhodes. Joshua is a landscape photographer, so it doesn't mean that you must be an astronomer or amateur astrophotographer. Just a landscape photographer, but you just take the landscape with this barn here, farmhouse, and the land here, and then you see the sky above. All right. Of course, you see here the Pleiades. All right. You see Orion here. All right. Great Orion Nebula, Rigel, Anita, Anila, Mintaka, and you see also the zodiacal light. All right. Some Malaysians have taken pictures in the evening sky. after sunset, the dusk or dawn sky, they have seen a lot of stars and also the zodiacal light. So what's the zodiacal light? Zodiacal light is basically the sun, the light from the sun, as it passes through all the planets, it will hit the disk of dust that is still orbiting the plane of the solar system. Or our Earth is embedded in the zodiacal dust. All right. So as the light scatters back from the dust back to Earth, you see this dust. All right. And of course here you see of course the Pleiades star cluster in Taurus and Mars. But here there's an interesting statement here made, not confirmed yet. So recently, remember the Juno spacecraft sent from what they call Earth to what they call Jupiter, and they found that a lot of those particles of dust will hit the solar cell of Juno and will scatter out, and the camera in Juno capture those particles that will kick off from the solar cell and flew back into space. And from the investigation, they said that the particles of dust that came and hit the solar cell panel came from Mars. So now there's a new theory they want to confirm very soon on that it could be that the zodiacal light, all right, was originally because of the dust storm, the global dust storm on Mars, kicked out some of those dust particles into space and orbited the solar system, and some of them hit the solar cell panel of Juno and they detected it. So this is not confirmed. So they are not investigating it vigorously. So it could be the zodiacal light came from the dust storm on Mars. Very interesting. All right. Now we go to the next one. Mars 9. This is the one who must explain more. I hope Lai will give me a bit more time. So okay, now I see Mars 9. It's a bit slow. Make it bigger first. Mars 9, you see here, perseverance 360 degrees, unusual rocks, and the search for life on Mars. All right. NASA, JPL, Jet Propulsion Laboratory, Caltech, California Institute of Technology, Pasadena, ASU means Arizona State University, MSSS, the Marine Space Science System. It's a famous kind of research organization in San Diego, California. So basically here, you see this picture, I can enlarge it. I can enlarge some more. I can go left, whichever. So it's actually a 360-degree panoramic view of Mars. Now I make it a bit smaller. You can join from one end to the other. There you are. So basically, what is explained here by NASA is, so NASA is challenging many of the people in the world, do not take this picture completely as it is. What you do is to enlarge it. Very, very high resolution. And maybe you can find here, they say, NASA, I don't know whether it's tongue-in-cheek or not. They want to, what they call, make fun, is that you can find a skeleton there. You can find some fossilized type of creature there, a plant that is fossilized on the rock. And many could be, you can find a lot of interesting things here. And if you find anything interesting here, which you have to explain, please put in your social media. Maybe NASA will know about it, and maybe you have made a discovery. So basically, this is a kind of not very well studied picture yet. So NASA is still studying it. So you see, I enlarge it. It's fantastic. So much information you can get. So what you do is, you have to slowly look at this picture day after day for some weeks, and maybe you can find something interesting on Mars. All right, it's a panoramic view. All right. So remember, where is this? This is on the western close to it's inside Jezero crater on Mars. All right, but close to the western rim of the Jezero crater. All right. So now remember, Perseverance rover is still very near to where it landed, and maybe on the 8th of this April, Ingenuity helicopter will do the first flight. Right. It's only later, many months later, that what they call Perseverance will start moving over larger area on Jezero crater. All right. Remember, the mission lifetime of this Perseverance rover is one sol of Mars. One sol means one year, solar year on Mars, which is equal to 2 Earth years. So Precision rover will explore Mars for 2 Earth years. We hope it will make a lot of discovery. Of course, the most important is you will find whether there's evidence of this life on Mars or not. Fossilized microorganism. Of course, they know Mars got water, all right? By the earlier mission, all right? This sojourner, spirit, opportunity, and curiosity. But actually, whether they can detect where is the water on Mars, all right? Of course, there are a lot of frozen water ice on Mars solar polar cap, but see whether there's evidence of water. Some of people say that water could be trapped below the surface of Mars. So you can keep on exploring this picture and enlarge it. There's so much information you can get. No, I say, what is this? Hey, what is this? It's a shadow, huh? It looks very interesting. I thought this was a 10 pin, you know, go to the bowling alley, you hit a 10 pin, a black colored 10 pin. It's not, all right? So I go to so this is the last part for me, all right? So we pass over to Zhengyang, all right? Okay, Zhengyang, you're on.
Okay, so I will start my presentation with the APOD picture on the 4th of March. So with the title Mars in Taurus. So this is the author Peter Hololex. So he is an astrophotographer from the Czech Republic. So here you can see the Mars, which is orange in color. So it's now the home of Perseverance rover. So in this picture, the Mars is passing through the constellation of Taurus, and it has a conjunction with the Pleiades star cluster, which is this blue in color. And so when at night, so we can see the Mars easily with our naked eyes. So although it looks small, but it is red in color, so we can differentiate it from other stars. So above the star, there was the Pleiades star cluster, which is this. So it is also known as the seven sister. So in the Greek mythology, Pleiades were the 7 daughters of the Atlas. So there are 7 main stars, which is bright and easily be seen as the 7 daughters. But this is an open cluster, so actually it has hundreds over stars. So we can say it mainly is blue in color is because of most of the stars are younger stars which live for a shorter time and is blue in color. So next, there was a beautiful picture of the California Nebula. So its name so is because of its shape is like California. So it has a high apparent magnitude. This means it is darker and it's difficult to observe visually. So it's an emission nebula which will emit light on its own. Next, so you can see on the left side of this picture, you can see the highest star cluster, which is here, very small here. So it's the nearest open star cluster with the group of hundreds of stars. So it's located at the V shape of the constellation Taurus. So the V shape is actually here. So Taurus is actually a bull shape, and then the V shape here is actually the bull's face. It's on the bull's face. So in this cluster, we had found the first gas giant of exoplanet among all this open cluster. Next, here you can see the brightest star here. Its name is Aldebaran. So it's the brightest star in the constellation of Taurus. So it is at the position of the bull eyes. This means as the Taurus, the eyes there. So it's also is the end of the V shape here. So V shape here. So it is a giant star which cooler than our sun but larger radius than our sun. So Aldebaran is believed to host a planet several times than mass of Jupiter, named Aldebaran B. So we can realize that here have some part with the dark area, which is the dust cloud. So this is a group of dust that block out the light from the background stars. so we cannot see through the dust to observe the star behind it. Okay, so I will proceed to the next picture, which is the 3rd of March. So this picture is named Star Over the Erupting Volcano by the Crucible Valley, Vela. Okay, so this is the mountain of the Etna. It's located in the Sicily, Italy. It's the highest active volcano in Europe now. It is one of the most active volcanoes in the world. This has brought many problems for the villages nearby, but also bring benefits to the villages by improving the agriculture with the fertile volcanic soil. So now there's a tourist attraction with thousands of visitors every year. So we can see here is actually the mountain Etna, but yeah, there we can see got many people is visiting there. So in this picture we can see got some place with the white line. So this is not meteor, but it is actually the satellite trail. So this is not a meteor, is because a satellite trail is brightened and dim in a regular pattern that seems like this. So if it's a shooting star, or we call a meteor, that will show a light that brightens and then will be darker away as it moves. So here we can see some white place. Okay, so that's snow, because we need to remember that this is a high mountain and now the temperature is about 1 degree Celsius, so there are snow. But of course, above here is the snow had already melted by the lava. Okay, so here we can see the lava plume which shoot upwards into the atmosphere during the volcano eruption, and there were also hot lava flows down the mountain. So here everywhere the lava. So the temperature of the lava can up to 1200 degrees Celsius. So it's quite hot. It's really hot. This volcano eruption was so strong that nearby airports were closed to keep planes from flying through the dangerous plume. Next, okay, we can see that above this lava plume is something look like a little diaper, but it's actually just a little diaper like asteroid. That means that it is a pattern of stars that is not constellation. So beside here we can see a very bright star. It's named Borealis. So it's the shoulder of the Orion constellation. So although it has a distance of about 150 light years away from Earth, but it has an apparent magnitude of about 1.6, so we can easily see it in the night sky with our naked eyes. So above here, very small on top of this picture, we can see the Lambda Orion cluster. So it is an open cluster and in the constellation of Orion. So here the brightest star here is called Messier, so which is at the head of the Orion constellation. So lastly, this image foreground and background were captured consecutively by the same camera and the same location. That means that this picture is taken separately and combined together after it. So I proceed to my last part, which is on the 2nd of March with the title Ingenuity, a mini helicopter now on Mars. So this is by NASA and also JPL. So Ingenuity is a mini helicopter that brought by Perseverance to Mars now. So it had arrived Mars but not yet deployed. So it is planned for deployment in about 8 April 2021 and make its first flight. It is a part of mission 2020 by NASA. So it's a technology demonstration to test the first power flight on Mars. So once the rover reaches a suitable heliport location, it will release the Ingenuity to perform 5 test flights over a 30 Martian day. So the first flight will just fly up 3 meters. It's just about 1-story house high. So it's quite not really high. So it has also the potential to scout the location of inches and support the future planning of the driving routes for Mars rovers. So the important thing on it is the camera, which will take a lot of picture and send back to the Perseverance, and the Perseverance will send to the orbiter cruise, and lastly send back to Earth. So this helicopter is not only can control by human, but it has also many of autonomy to make its own decision about how to fly to a waypoint and keep itself warm through the intensely cold Martian nights and charging itself with the solar panel. So the most challenging for it to fly on Mars is Mars has a thin atmosphere. It's about 99% less dense than Earth. So this helicopter need to be light and has bigger rotor blades and spin more faster to lift it off. So the speed of the rotor blades is many times faster than the blades would turn on a passenger helicopter here on Earth. There are also advantages to fly a helicopter on Mars, like the gravity on the Mars is 1/3 of the gravity on Earth, so it is easier to lift it off. But of course, the challenges is greater than its advantages. So if this demonstration is success, then will really help the robotic flies work on other celestial objects developed in future. So this technology will not only use on Mars, but also other like Titan. Now, the helicopter is still attached to the underside of the rover. It has folded out and put sideways. So it's look like this. Oh. Okay. Okay, so it look like this. So we can see here is the body and the blades, and the leg is here. So recently the protective covering was released, which is this. After that, the 4 legs will be deployed one by one to let it facing the ground, and then the helicopter will be lowered to the Martian surface. So for the first flight, the rover will be standby to record this memorable event. So lastly, this imaging is not this picture is not the imaging picture, but it is an illustration. Okay, it is the end of my part.
Mr. Lai, you are on.
So I'm on. So good evening, everyone. So it's me again. All right. I believe you have seen me for a few months in this APOD session. And now let's start with the 8th of March. I'd like to share screen. Let's see this. So can you see my screen?
Yes, Lai, can see.
Okay, so the 8th of March is a Neowise comet. All right. It's an image or a photo taken by Nicolas Latudo, right? A French optics engineer and also amateur astrophotographer. So Comet Neowise, all right. I believe that many of us are familiar with this Comet Neowise, and then we have this Comet Fever last year, right? In July, even our ASP also we have this observation in Balik Pulau. Everywhere in the world they are observing Comet Neowise, all right. And observing this Comet Neowise, we do not need a telescope or what. We just need a pair of binoculars, or even naked eye, we can see this Comet Neowise. Just that we can't see such nice comet. The quality of our eyes might not be as good as long exposure camera. So this is the image of this Comet Neowise. So usually for a comet, we have 2 types of tails. One is the ion tails and one is the dust tail. So the same goes to Comet Neowise. We have 2 tails, but over here the caption said 3 tails of Comet Neowise. All right, it looks like 3 tails because the ion tails have two different color, a red tail and a blue tail. Right? Why there's a red stream of red ion tail is because there are these gases emitted from this comet nucleus, which is rich in sodium. Sodium atom is excited. So when this sodium atom is excited, it emits red light. So we have a red tail and a blue tail. So we have, it seems like it have two ion tails. So it gives the name of a three tails of comet Neowise. Right. And then we have a white dust tail. For a comet, you will see two tails, right? The ion tails and the white dust tail. So dust tail is white, right? It's actually white and curved. All right. Why is white and curved? Because of the solar pressure. So if I scroll, I put my mouse over here, you can see there's an arrow below here showing that there's solar wind. So the solar wind exerts pressure and pushes the dust tail backwards. All right. And because of our most comet, or all of the comet, they're actually orbiting the sun in a Keplerian orbit, which is for comet usually is highly elliptical orbit. So they will follow the orbit, so it will be curved. All right, it will be curved. So a little bit more information about this comet is, this is the coma, the green coma. Right, the coma is large. All right, it can be larger than our sun. Okay, it's actually ionized. Right, it's actually ionized from the nucleus, get ionized, and the envelope of ionized gases forms the coma. So it's big. But the nucleus itself of the coma, the nucleus itself of a comet is actually very small. All right, usually not more than 30 kilometers. So this is about the comet. And just add a little bit more information. So as this comet, the nucleus getting closer and closer to the sun, all right, slowly it will be heated up, so ionized, and some large particles, okay, will be ejected from the nucleus as well, so forming a nucleus, forming a debris stream. So when our Earth pass through this debris stream, what will happen is we will see this meteor shower. All right, so every year we have some meteor shower that is come from comet. Right, so this is it. Next, we have 7th of March. This is a nebula image captured by NASA, which is from the Hubble Space Telescope. So most of these nebula or nebulae images is actually taken from Hubble telescope. And this is an infrared image of Eagle Nebula, which is located in the constellation Serpent, which is at the tail of the snake. All right. So our eyes is actually have very limited visible, very limited range can observe very limited range in this electromagnetic spectrum. All right. In the electromagnetic spectrum, we have different wavelength. The smallest one is X-ray, and then we have UV, and then visible light, and then infrared. So this is the infrared image. If you are familiar with this pillar of Eagle Nebula, you might think something like this. All right, is like something looks nicer, but this image, this photos looks quite different because this is infrared. Our eye cannot see infrared. Infrared is actually larger than the red light wavelength, which is more than 750 nanometers. But we can't see infrared, but we can feel infrared. It actually we have this infrared in the form of heat, right? So usually we use this infrared technology a lot, especially in this airport, especially at these special times, right? They scan your temperature. How they scan your temperature? Higher temperature, it appears redder, right? And then it will be blue if the temperature is low. So in this, there's no legend saying that whether this is higher temperature or lower temperature, but usually or commonly, it will be brighter for higher temperature region. So we can presume that this part is slightly higher temperature. All right. So this is it about this infrared image of Eagle Nebula. And a little bit more information is there are also new stars forming in this Eagle Nebula. All right. So next, we will move on to the next one, which is the last APOD picture of the month, which is images by Robert Barsa. And this image, the title given is A Little Like Mars. All right. So this circle here, it looks like planet Mars. But in fact, this is not planet Mars, but this is the Atacama Desert. When I first see this caption below, it says Atacama Desert, it reminds me about something, which is the Alma telescope. Alma, it stands for Atacama Large Millimeter Array. It's a radio telescope array, consists of 66 radio telescope. And this Alma is a part of EHT, Event Horizon Telescope, which have recently, I think early this week or somewhere last week, they have actually published the new image of this black hole 87. 2 years back in 2019, actually, when we have the first image, first image of black hole, which is on 2019. We actually have a live press conference, and then we follow that. ASP also follow that. And then this year, more discovery is about this, which is they managed to study and discover. Actually, they discover the magnetic field behavior of the black hole. Right? They polarize the light, and then they get the magnetic field behavior. So this is a new discovery from this EHT, and Alma is one of these. But in this picture, Alma is not inside this picture, okay? But is located in this Atacama Desert. So in this picture, we can tell that this picture is taken on the southern hemisphere. Why? Look at the Orion. The Orion is opposite, right? The Orion Belt is here. Orion Belt is here, and then usually Betelgeuse would be somewhere up here, right? But this time Betelgeuse is down here, right? It's the yellowish, reddish blue star. It's a bright star, brightest star in this Orion constellation. So it's down here. Why? Because it's taken in the southern hemisphere, so Orion appears in the opposite side. And Rigel is here. Rigel is the second brightest star. Sorry, the brightest star is Rigel. The second brightest one should be Betelgeuse. So Rigel is here. And the hunter's bow is here. The sword is here. So I think we are familiar with navigation using Orion. Orion can tell us this direction. So in this case, all right, the Orion Belt usually aligns from east to west. So this time, east is over here, and west is over here. East is over here, west is over here. And also the Orion sword always pointed to the south. So south is up here. All right, so this tells us the image is taken from the southern hemisphere, which is Atacama Desert in Chile. So over here we can see also Mars, Pleiades, and zodiacal light. Right, zodiacal light. And Dr. Chong have give quite a detailed explanation about this zodiacal light just now. So I think we don't go further into this. So just slightly a little bit more about this image is this is not taken as one image, right? This is a mosaic. That means it's a composite image. It's divided into a few parts and then stitched together. Right. So this is it about the APOD for March. From us, ASP, we have, again, thank you. We thanks Dr. Chong, Zenyang, Marcus, and Ryan. So if you all have any question, we welcome all kinds of questions in this Facebook comment session or the YouTube comment session. So we'll try our best to answer all your questions. All right, so is there any questions?
Yeah. So Michael, Mr. Lai, any question for us?
There is no question on either side.
Yeah, we don't see any questions. So I think it's about time. Can we call this a session?
Okay.
Any comments from Dr. Chong's or our discussion panel?
Yeah, so like I got just one comment. This last picture is very good. So basically, this is called the common term is called a little planet projection. But the technical term is called a stereographic projection. So what is a stereographic projection? It is projecting a three-dimensional surface in three-dimensional into a flat surface. It's called a stereographic. So the stereographic projection got two types. This is the first type called little planet projection where the nadir is the point when you're standing on the Earth's surface, the nadir is the point below you. So the nadir is in the center of the picture. So in this case, it's called what we call little planet projection, where the nadir is in the center. But if you put the zenith is in the center, that means basically, like you said, you take a lot of pictures in a panoramic direction, 360 degrees, and you stitch up with the software. So if you put a little planet projection, the nadir is in the center. But if you put the zenith in the center, then the picture will look like a tube. That means the in the center of the tube is the whole sky, but the ground will be the wall of the tube. So these are the two. But this one you are using is called little planet projection. Very nice. I really like this picture. Very nice.
Yes, and then you can also see the Milky Way over here. See, Milky Way.
Yes,
so,
yes.
If our audience, any one of you from Penang, you're interested to observe the Milky Way, you actually can go to some dark places in Penang. Not necessary that you have to travel to this Atacama Desert or travels overseas. Any places in Malaysia, you have dark sky, even Langkawi. Langkawi is a good place, I think, Dr. Chong.
Yeah,
right?
You know what?
We have a lot of beautiful image of this Milky Way.
Give me a good idea. I go to a beach in Langkawi where there are, I can get a panoramic view of the coconut trees. So I can see one coconut tree, all surrounded by coconut trees. Wow, very nice. Or even better, a flat plantation of durian trees. So all the durian trees will be poking up from the earth. That would be nice.
I think coconut tree better, don't durian tree.
Yeah. So some people put for little planet projection what? Like they go to a skyscraper in America, a lot of skyscraper, they take a 360-degree panoramic, so they put in a lot of skyscraper poking out all around the horizon. Very nice. Any question for any one of you? Marcus? Ryan? Zheng Yang?
So if we don't have question, I think it's about time. We can call it a session today.
Yeah.
So
you can call it a session. We have a short discussion after this, huh?
Yeah.
Huh?
So before we end our session, all right. I'd like to remind our audience, this airport session we are having it at the last Saturday every month. So if you are interested to know what's the airport session, what's about the airport for April, follow us. All right. You can follow us on our Facebook, Instagram, and YouTube. This is our QR code for this. Scan and follow us. And also the upcoming event for April. The first one will be on 10th of April, which we will have a brief introduction of all the observatories in Malaysia. For information, in Penang, in Malaysia, we have a lot of observatories. And in Penang itself, we have 9 observatories. And I believe the number 10 is coming soon as well. So stay tuned and follow us. Follow us on Facebook, Instagram, or YouTube to have more information about our upcoming events. And do join us for the observatory introduction in April. So once again, thank you everyone for following us and having patience with us for this airport session. So hope you all have a nice day. Good night.
Yeah, for those who are following us on YouTube, remember to like, subscribe, and subscribe to our channel. All right? Thank you.
Right. So thank you.
Bye-bye.
Bye-bye.